In this short lecture, we are going to prove that norm 1 is a norm on Rn. And to show that, we are considering that let x belongs to Rn, and then norm x1 is given as the absolute value of the component of x. And to show that this norm 1 is a norm, we have to validate these three properties. And so let's start with the first one. In the first properties, we have to show that norm x is greater than 0 and norm of x equals 0 if and only if x equals 0. So since we know that the absolute value of any number is non-negative, so the norm of x1 will be greater than equal 0. Now the equality 0 holds if norm of x1 equals 0 holds if each component is 0. So that means here I equal 1 to n, absolute value of xi is equal 0 if and only if all xi is equal 0 for I 1 to n, and which in turns give us x is equal 0. Now come to the second property, which is stated as norm of alpha x1 is equal. Now when we multiply a scalar with the vector x, then each component will be multiplied by alpha. So here is alpha norm of alpha x1, alpha x2 and alpha xn. So with the definition of the norm, so this is equivalent to say absolute value of alpha x1 plus absolute value of alpha x2 plus so on absolute value of alpha xn. Now absolute value of alpha that can be taken out, and then you will get it here mod of x1 plus mod of x2 and continue mod of xn, and which is nothing but the norm of x1. So this validates the second property. Now we will prove the third property, and for the third property we know that the absolute value inequality, the triangular inequality for the absolute value, which is written as mod of a plus b is less than equal mod of a plus mod of b. Now with this general property we can use it to prove the third property. So now for x belongs to Rn, y belongs to Rn, so we have norm of x plus y 1 is equal norm of x1 plus y1, x2 plus y2 and continue xn plus yn norm 1, and by definition this is equal mod of x1 plus y1 plus mod of x2 plus y2 and so on to give you mod of xn plus yn, which is less than equal mod of x1 mod of y1 plus mod of x2 mod of y2 and so on It will be mod of xn plus mod of yn. Now combine this, the part of x, component of x and component of y. Okay, so this is given now the absolute value of norm of x 1 plus norm of y 1. So this proved the third property of the norm. So therefore finally we can conclude that norm 1 is the norm of Rn.